Hello learners, this is Habeeba with Excelwithme. If you like the video, please do like, share, subscribe and comment below. Let's start today's class, that is descriptive statistics, with the subtopic measures of relative positions, percentiles, percentile ranks, standard scores, sigma scores and t-scores. Let's start quickly with the measures of relative positions. When we administer a test on a sample of students drawn randomly from a population, the scores obtained are raw. So, a raw score on a test taken by itself has no meaning. We are collecting the, maybe we have chosen a questionnaire. We will give the subjects the questionnaires and they will fill it up and we bring that data, that is the raw data. So what we have to do now, it gets meaning only by comparison with some reference group or groups. One data to the other data, we do the statistical treatment and will compare those. The comparison may be done with the help of the following measures. Number 1, percentiles, 2, percentile ranks, 3, sigma scores, 4, standard scores and 5th one, t-scores. So let's understand first one, that is percentiles. Percentiles are the points which divide the entire scale of measurement into 100 equal parts. They are denoted by P1, P2, P3, P4, P5 and so on, P99 and P100 you can see here. Now the first percentile may be defined as that point in a frequency distribution below which lie 1% of the total measures or scores. So similarly 20th percentile may be defined as that point in a frequency distribution below which 20% of the total measures or scores fall. It is evident that the median expressed as a percentile is P50. So it should be noted that P0 lies at the beginning of the distribution and P100 at the end of the distribution, as we can see here. P0 it starts with and ends with P100. When we take the 50 half percentile, that is P50 median, it will fall over here. So the formula for calculating percentiles is capital P denoted with the small, that is percentile, equal to L, small l plus Pn minus F upon Fp multiplied by I. Let's see what are these denotes, in which Pp is percentile of the distribution wanted, then L exact lower limit of class interval upon which Pp lies, then Pn part of the n to be counted off in order to reach Pp. F is sum of all scores upon intervals below small l. Then Fp, number of scores within the interval upon which Pp falls, and then I is length of the class interval. If suppose class interval is 10 to 15, class interval will be 5. 10 to 20, then 10. That length of the class interval. The use of formula may be illustrated by the following example. Calculate P25, P45 and P95 from the following distribution. Let's see the distribution here. The calculation of percentiles from data grouped in a frequency distribution, that is scores are given here. Class intervals 81.5 to 86.5. This is the higher limit, upper limit, and lower is the 41.5 to 46.5. Frequencies are given, that is n. Total number is 80. Here cumulative frequencies are given 2 plus 2. I'll show you here cumulative how we take it. This 2 plus 2 will be 4, and then 4 plus 9, 13, then 13 plus 12, 25, like that we add upon to come to this count, that is total number, that is 80. Then for computing P25 we have to first find Pn. Here 25% of 80 is 20, Pn equal to 20, that is we have taken here. Now L equal to 55, that is lower limit we were talking about, 56.5, and then F equal to 13, FP equal to 12, I, that is class interval, that is 5. Between, what is the class interval in between? Now using the formula we can calculate this. 56.5 plus 20 minus 13 upon 12 multiplied by 5, we get the answer 59.42. Like that we have to calculate. Similarly P45 also we have the formula. According to that we have to calculate P45 and then P95 similarly. Now percentile rank, second one. The percentile rank is the point in the distribution below which a given percentage of scores falls. That means if the 80th percentile rank is a score of 65, then 80% of the scores falls below 65. So the median is the 50th percentile rank, for 50% of the scores fall below it. Now the process of calculating percentile ranks is the reverse process of calculating percentile points. Just we have seen, we have to calculate ranks corresponding to particular scores. If R is the rank and N is the total number of cases, then the percentile rank equal to 100 minus 100R, that is ranks, minus 50 divided by N. So suppose our ranks 30 in the class of 80 learners, 12 learners rank above it, 67 below it. Its percentile rank is given below here, that is answer 84. So we will calculate with the help of the formula. The third one is sigma scores. A sigma score makes a realistic comparison of scores possible and provides a basis for equal weighting of the scores, as the scores on different tests are expressed on a scale with a mean of 0 and standard deviation of 1. So let us suppose that the mean of a test is 75 and the standard deviation is 5.0. Then if A earns a score of 85 on this test, his deviation from the mean is 85 minus 75 equal to 10. That means dividing this deviation of 10 by the standard deviation, we give him a score of 10 upon 5, that equal to 2. If B's score on this test is 64, his deviation from the mean is 64 minus 75, that is minus 11, and his score in standard deviation units is minus 2.20. Deviations from the mean expressed in standard deviation terms are called sigma scores. That means half of the scores in a distribution lie below and half above the mean, and about half of standard deviation scores are positive and half are negative. Fourth one is standard scores. The sigma scores, which are often small decimal fractions and half of them are negative and somewhat inconvenient to deal with. So what we do here, hence scores are usually converted into a new distribution with mean and standard deviation, so selected that it makes all scores positive and relatively easy to handle in computation. Such scores are called standard scores. Generally we use this a lot. The formula for the conversion of a raw score to a standard score is as follows. Here mean is equal to standard deviation square divided by standard deviation. Here you can see the formula to calculate standard scores, in which total, that is x upon 1 equal to 14 standard score in a new distribution. Like that, standard deviations of standard and raw scores are here given. Then a score in original distribution is x. Then m and m equal to means of raw and standard scores. Now let's see the fifth one, that is t scores. The value sigma z score in most of the cases is expressed as scores with decimals or negatives. In order to avoid this type of situation, another version of a standard score, the t score, generally we use a lot, this one has been devised. So when the mean and standard deviation we taken to be 50 and 10 respectively, the standard score is called a t-score. Here again formula is given here. You can see the formula to calculate the t. So let's see the example here. To illustrate, let us consider a distribution with its mean 67 and standard deviation is 12.5. Let us also suppose that A's score is 76 and B's score is 54. Now express these scores as standard scores in a distribution with a mean of 250 and standard deviation of 50 and t scores. Let's see with the calculation with the help of this formula. Here calculation is given. You can zoom in and see the calculation, and you can practice this about the substituting A's score of 76 in the above equation. We have here given 286 and B's as 198. So using formula T, we can calculate like this. Substituting A's score in the above equation, we have 57.2 and B's score 39.6. You can see the formulas, you can note down, you can stop or pause over here and you can note down the formulas and you can check it out. So we come to the end of this session. If you like the video, please do like, share, subscribe and comment below. I'll come up with the next class in the next video. Thanks for your attention and time. Happy learning.